Welcome to CS3308 Information Retrieval. This is the Unit 1 lecture, Part 1. During this lecture, we're going to accomplish a couple of different things. First of all, we're going to provide a basic introduction to information retrieval and attempt to define what is it. Secondly, we're going to cover a little bit of the history of information retrieval. Where did it come from? What kinds of things drove its development? And then finally, we're going to look at a couple of the most basic information retrieval models, because we're going to look at both the Boolean model and the ranked model. So let's just kind of jump into that and talk about what exactly is information retrieval. So we have kind of a real simple definition here, and it's the process of finding any kind of relevant information. Well, the idea is that we want to have some form of a system. In our particular case, a computerized system, but that allows us to find relevant information. And you notice this relevant is very, very important, because we can find information. Information is easy to find. What's sometimes difficult to find is the particular information that we want to have to answer a question or to solve a particular problem. So any kind of relevant information, and that's what information retrieval is ability to find it. Now, what can we find and where do we find it? Well, obviously, it can be in web pages, it can be, information in news events, books, things of this nature. Relevance is obviously a key notion, and I have a bunch of different logos at the bottom here, and you're probably recognizing these as search engine providers. So we've got Google over here, I've got Yahoo. These are a couple of the larger search engine providers. Bing, obviously, being the Microsoft version, Alta Vista. Autonomy is a leading provider in enterprise search. So where these companies here, Yahoo, Google, kind of search everything in the internet, or provide the ability to search everything in the internet, Autonomy is a little bit more focused in the sense that where they play is they provide to organizations the ability to search all of their own internal data. So this whole idea of looking for, finding, searching for information, that's really what the discipline of information retrieval is all about. Now, where did it come from and a little bit of the history. A lot of folks will accredit Vannevar Bush, this gentleman here, who wrote a paper. And the paper, by the way, was entitled As We May Think. You can go out and search it on the internet, find it. I recommend that you do read it. But in this paper, which was written back in the 1940s, Vannevar Bush kind of described the information retrieval solutions that we have today, because he kind of defined the need for it and the requirements of it, and provided, quite frankly, an excellent operational definition of what the information retrieval systems that we have today should look like and operate as. It wasn't, however, until 1951 when Philip Bagley, actually as part of a master's thesis, started to do some of the earliest experiments in computerized information retrieval using a computerized system as part of an information retrieval solution. Another key point is that this whole concept of information retrieval has really been owned by library science as a discipline. It makes sense, right? Because library science really is about trying to find information, trying to find the right information, finding the right book. And of course, that's where the sweet spot is, if you would, of information retrieval. So really, library science has been one of the more seminal contributors to the discipline. Another one that's important and relevant to point out is law research. So if you can think about the job of the attorney, one of the things that attorneys want to do is they want to find relevant case law. They want to find cases, court cases that have been that have been judged on or adjudicated by a judge, where a decision was made, and a decision that is similar to the one that they want the judge to make. So they can kind of bring these cases to the judge saying, gosh, we're asking you to do something that other judges have already done. So this ability and this need to be able to find specific cases that have been settled in a court was a key contributor to information retrieval. And as you might think about it, the ability to search for something, well, in this case, they're searching for cases that fit the particular model that they're looking for. Another thing has been companies such as LexisNexis who have exploited this information search and retrieval capability as a business model. So all of these things led up to the development of the internet search players, which we started to see being introduced in the mid 1990s. So Yahoo comes along, and not too long after that, we wind up having Google, and of course, as they say, the rest is history. So I wanted to just define a term, and you're going to see this term come up in your readings, and I just wanted you to understand what it is, but the term is called a corpus. Now, a corpus, think of it as a collection of documents. So, for example, you're going to see throughout our text, they're going to talk a lot about the Reuters corpus. And think of this as a series of, and Reuters is a news service. It's very similar to the Associated Press, AP, and there is a large collection of postings or news press postings, articles that were written by writers, journalists, and then submitted to Reuters over the years. And this very, very large collection of documents is referred to as a corpus. Now, what makes it a little bit unique is that all of these documents in the corpus have been evaluated and categorized manually. So we kind of know what's in there. And we've looked at it, and we've categorized these documents. And the purpose behind this is again, so getting back to the concept of information retrieval, it's all about finding relevant information. Well, how do we know what's relevant? So when I start developing solutions to go out and search and find information, I needed to have a way of saying, did it work, right? Did it work? So what you find in the corpus is that we have a whole series of metrics that basically say if you execute specific kinds of searches, you should get these kinds of documents, these specific documents that are returned. And that's what's unique about a corpus, is it has the metrics defined around it, and such that when I sit down and write an information retrieval type of a solution and execute a search, I should get back the documents that I already know should be returned. It's just a great way of testing whether or not my information retrieval system is working. So the corpus is a well-known collection of documents that has metrics around it and specific searches and what the responses of those searches should be. So it's typically used to test the reliability and precision of information retrieval systems. Now, we're not going to use a full corpus in this class. One of the reasons why is they tend to be very, very large, and it becomes a bit unwieldy to work with all that information. We are going to use a much more limited subset, and to that limited subset, we'll have some understanding of what the metrics would be. I just wanted you to have this concept, though, of what a corpus is and how it's used generally within information retrieval research. Now, we're going to talk about the two retrieval models, and we're going to get introduced to these two models rather quickly as we go throughout the course. And one of them we're going to actually be developing an information retrieval system around. So the first one I want to talk about is the Boolean retrieval model. Now, if you think about Boolean, you probably recall that Boolean refers to kind of a logic expression that will evaluate to true or false. And so a Boolean retrieval model is one in which the query that I ask, so when I go and search for some information, the way that I'm going to determine what to return is whether or not a document matches or does not match the query that I gave it. And the way that we do that is we use these traditional Boolean terms of and, or, and not. So for example, I might want to search for something such as home, mortgage. Now, in a Boolean retrieval model, I might want to say, I want to search for the terms home and mortgage. And what that basically means is that any document that has both the terms home and the term mortgage within it would be true and therefore returned. So this gives us a way of executing a query against a group of documents, and if it meets the terms, then it's actually going to be returning the information. Now, the problem you run into with this is that in some cases, it doesn't tell me how relevant it is. I mean, just all it's telling me is that it has the words home and mortgage within it. So, although it's useful, it may not be really all that useful because it doesn't help me to understand in many cases how relevant it is. All I know is that it has those particular terms. And, however, this was the primary commercial way that we did retrieval for many, many decades. So all the way since the 1950s up till, roughly into the, into the 80s and beyond, this is what we typically had. There are still a lot of search systems out there that still use this kind of Boolean type of nomenclature. And you usually can identify them because you're going to see these terms. You're going to see the terms and, or, and not used in the queries. The other one that we want to talk about as a retrieval model is ranked retrieval. So basically the idea of ranked retrieval is that I'm going to have some query nomenclature that I'm going to use. However, what's different about ranked retrieval is the fact that I have a way beyond just include or not include a document to determine what is retrieved. So I have some set of conditions that can evaluate relevance. So, I might have the idea that that I might want to have, my terms of home and mortgage. So, for example, home and mortgage, let's say that these appear rather frequently in some documents and not so frequently in other documents. And let's also assume that, this term mortgage is not all that frequently appearing in documents in general. So it might rank this higher when I have these terms appearing more in the documents, indicating that perhaps it's more relevant to what I'm trying to understand, which is home mortgages. So the basic difference with the ranked retrieval model is the idea that it can order stuff based upon relevance. And oftentimes the relevance metrics that we're going to look at in this class, although there are many ways of doing this, and quite frankly, Google, our good friends Google, they've kind of made an entire business model out of this concept of how you rank. And in fact, they've come up with their own algorithm called PageRank. And it kind of forms the basis of their whole business model, and it's one of their most important technologies and competitive differentiators. So again, ranked retrieval model has this ability to order the documents that are returned based upon some calculated relevance, and oftentimes, in the way that we're actually going to do it throughout the remainder of this course, is we're going to use concepts such as frequency. So how frequently does these terms appear in the documents that I'm searching? How frequently do they appear in general in documents? So for example, if I had the word the word the in English is going to appear frequently in a document, but it's also going to appear in just about every single document out there. So that's not going to be as relevant perhaps as this idea of the word mortgage that appears frequently in a document and does not appear frequently in all documents that I might have in my collection. So anyways, we'll